Welcome to week 4. We are going to start out with a Normdist function. So that's going to be pages 26 and 27 in your Excel quick guide. And the first thing we're going to do, we're going to use the example that is in that actual quick guide. So they're looking at what the cumulative probability of a score is. And I think it's really important to remember that we're looking at the cumulative probability. So we're going to be looking at some spelling scores. It looks like students could get a total of 20 correct. So we're looking at the different scores. So I have my scores here, and then they have given us the mean, which is 14, and the standard deviation of 2. If you look over on page 27, it gives you that information. We're going to need some more scores in order to come up with that information on our own. So we're just going to go with what they gave us here. So for this function, what you want to do, we're going to try to find what the cumulative probability associated with our spelling score of 9 is. So I'm going to go over to the box under Normdist, which is the function I'm going to use. I'm going to press Insert Function, and I'm going to search for it, and it actually comes up right there. And then for my x, this is my score of 9, so I'm just going to click over on my box. We know our mean is 14. You can either type it in or find the cell. Standard deviation is 2. And then for cumulative, when you're doing Normdist, we always want to type true. You're never going to type anything else. And then you can just press OK. And then it looks like 1% is our answer. That matches up with what we get. So that's a cumulative probability that that score of 9 is going to occur in our set of scores out of a total of 20 possible points. So we could do this for some other scores as well. We could go down to 13. We want to insert our function. Normdist is already here. Then again, our x is 13. Our mean is 14. So there you can already see that's going to be a little bit different, right, than our score of 9, because this score of 13 is far closer to the mean than the other score is. So standard deviation of 2. And then cumulative, again, we're always going to type true. Press OK. 31%, that matches up with what we've got. So you can see if you're comparing these two, you're going to see that that cumulative probability is going to be different for a score that's much closer to the mean. Let's do 19 for the heck of it. One more practice here. Normdist. And I'm not going to go through all of these, but I would prefer in your homework if you do that, just so you get the practice of going through the function. It can be a little labor intensive, not super exciting, but good practice. Always type true. 99%. Okay, so thinking about our frequencies, our bins, where those cumulative probabilities increase, this is what you're going to see here as well. So if we wanted to try this out again with another example, let's say that out of a score of 100 on an eligibility quiz. For example, in one of the classes I teach, we talk to student athletes about all of the mini eligibility rules. There are a ton of rules that they need to be aware of so they can continue to study at the university that they're at and continue to play their sport. So we actually ask them these questions. So let's say out of 20 students, that would be a lovely size class, but that's not how it is. But anyway, 20 students take this eligibility quiz. They could get a score out of 100. So I have my 20 scores here that I've just listed. Some did very well, some did not so well. So I went ahead and just put them in order just because I like to have them that way. But first thing I want to do, because this is my entire group of data, I'm going to use this to find my mean. This should be a just a review from weeks before. So for my mean, insert function, I'm going to look at average. And then I want my group of data, press OK. Okay, so it looks like 79 was the mean or the average for the class. Now I want my standard deviation, so I'm going to do the exact same thing. Little reminder from last week. Pull that same data. All right, and 15. So I've got a standard deviation of 15. Wow. So what I want to do is go through the same process to find what the cumulative probability associated with these different scores. And I just pulled some scores that I was interested in. So 50, obviously this is a student that may not have done so well, so I want to see what that cumulative probability is. But then I also wanted to see some of these higher scores, maybe closer to the class mean, and then also a little bit or significantly above the class mean. So I'm going to start here at the top, insert my function, find it. My x is 50 for this case. My mean I know is 79. Standard deviation 15. And again, I always type true for cumulative. And I've got 3%. So looking at my scores right here, that should make sense. You know, if our mean is 79 and I'm looking for a score of 50, what's a cumulative probability associated with that? So then if I went up, I could go to the next one here. So 60. This should start to go pretty fast for you. Okay, you're going to see that there's an increase in that cumulative probability that someone's going to have a score of 60. All right. Oops. Helps if you select the correct function. Okay, so you would continue on down this list. We'll do one more just to see. Obviously, this should be a far greater percentage when we're looking at our cumulative probability because we are going down that list. So let's do one more for the fun of it. All right, 98, 79, 15, and true. Alright, yep. So you can see, and that kind of makes sense when we're looking here, there is a score that's above that. So that kind of lines up when I'm just taking a glance at the data to make sure that it's making sense for me. So I would encourage you, if you want to continue for your homework, to do all of these. If you want to use my example, if you want to play around with your own example, that's perfectly acceptable. I definitely encourage that. But again, it's just to get used to going through this process. So feel free to throw in some of your own data if you want.